Now let's see the part 8 of ionic equilibrium. Right. So we are doing ionic equilibrium of part 6. Part 8, right? So see the question number 7. Part 8 of ionic equilibrium. So concentration of Ag plus ion in saturated solution of Ag2C2O4 is, so concentration of this one is given, Ag plus value is 2.2 10 raised to minus of 4 per mole solubility, right, per mole. So you have to find the solubility product of Ag2C2O4. You have to find the solubility product, right? It is asked in 2017. So see the how it dissociate into cation and anions. So when Ag2C2O4, it dissociate into 2Ag plus C2O4 2 minus. So initial solubility will be S and it will become 2S and this will be the S, right? And initial concentration is also given, that is 0.1, right? No, it is not given. So this will be the solubility, right? So I will write solubility product of Ag2C2O4. It will be Ag plus raised to 2 into concentration of C2O4 2 minus raised to 1. Now put the value, Ag value is 2S raised to 2 and C2O4 2 minus will be S. So solve it. So 2 square will be 4. S square is S square into S. Then it will become 4S cube equal to KSP. Right. So this will be the equal to the solubility product. Now put the value now. So S value we know, right? Here this Ag plus concentration is given. So it is nothing but is your total 2S value, right? Ag plus means it is 2S value. So S will be 2.2 into 10 raised to minus 4 upon 2. Then it will be 1.1 into 10 raised to minus 4 per mole, right? Now put here. So it will be 4 into S will be what? 1.1 into 10 raised to minus 4 raised to 3 is equal to KSP. So multiply this, you will get 5.3 into 10 raised to minus of 12 is equal to KSP. This is the value for solubility product. So it is asked in 2017. So please write it down. Now see the question number 8 now. Solubility of AgCl, silver chloride, with solubility product. Silver chloride solubility product is given, that is 1.6 into 10 raised to minus of 10 in 0.1 molarity NaCl, right? So this is your sodium chloride having concentration 0.1. So when it dissociate into Na plus Cl minus, so its concentration is 0.1 molarity, right? And Cl concentration will be same, right? Because they are equal in equivalent. In the similar manner, when AgCl dissociate, it form Ag plus Cl minus, right? So this will be the S, this will be the S plus 0.1, right? Why we have written here Cl 0.1 more because it is coming from this NaCl, right? So it will be addition of these two Cl minus. So solubility product will be equal to S into S plus 0.1, right? Because it is nothing but it is concentration of Ag plus into concentration of Cl minus, right? So here addition of these two Cl will be coming. Now put the value. So put the value, then you will get S. So it is, we know Ksp value, solubility product, right? That is nothing but it is given 1.6 10 raised to minus of 10. So it will be 1.6 into 10 raised to minus of 10 is equal to S into S plus 0.1. Understood? So as we know, S is very small as compared to 0.1. So here S can be neglected. So it will become S into 0.1 is equal to 1.6 into 10 raised to minus of 10. So divide this 0.1. So S will be equal to 1.6 into 10 raised to minus of 10 divided by 0.1. So your answer will be what? It will be 1.6 10 raised to of minus 9. Why minus 9? Because this will be coming here in the upper part as a 10, right? So 1 10 raised to minus 10 will be reduced. So this will be the value of solubility, right? So please write it down now. It is asked in 2016, page 2. Now see the question number 9. Consider the nitration of benzene. Nitration of benzene. Nitration of benzene using mixed concentrated conc H2SO4 slash HNO3 if a large amount of KHSO4 is added to the mixture. So it is added to this mixture. The rate of nitration will be. So you have to you have to tell me the rate of nitration. It will be increase, decrease, fast or low. So let's see the explanation then. Question number 9. So when nitric acid HNO3 react with sulfuric acid H2SO4. So this is your nitric acid. This is your sulfuric acid. Right. So what will happen? It will form NO2 plus 2HSO4 minus plus H3O plus NO2 plus. Right. So now see, when NO2 plus, right, this is called nitro. It reacts with benzene. So what will happen? Each carbon of this benzene having hydrogen, right? So it will form plus and other part will form minus. So minus will attract this NO2. So formation of nitrobenzene is there. So formation of NO2 is there. So this is called nitrobenzene. Understood? This is called benzene, whose general formula is C6H6. This is called nitrate and nitrate plus. So basically when combination of HNO3 and H2SO4 is done, addition of NO2 is to the benzene compound happens. That is called nitration process. That is called nitration process. Right. When KHSO4 is added to this mixture, then it dissociates into K plus and HSO4 minus, which increase HSO4 minus concentration, right? So what will happen after adding this KHSO4? It dissociate into K plus HSO4 minus, right? So addition of this one will increase the concentration of this part, right? HSO4 minus is already there and one ion is also added. So concentration of this will increase. The equilibrium shift to the backward reaction. Hence rate of reaction becomes slower. So what will happen after increasing the concentration of HSO4 minus? Rate of reaction will be slower, right? Rate of reaction will become slow. Will be slow. Understood? Why? Because it will shift to the backward reaction. Backward direction. So please write it down. Now see the question number 10. My and ny3, two nearly insoluble salt, have the same Ksp value of 6.2 10⁻⁻13 at room temperature. Next compound is My and ny3 are nearly insoluble salt. Insoluble salts have the same Ksp. Ksp means solubility product of the compound. So it is nothing but 6.2 10⁻⁻13. Understood? At room temperature. Which statement will be true in regards to My and ny3? So let's see the explanation. So first I will explain My. So when My dissociate, it will form My plus Y minus. So solubility product will be nothing but it is S into S. That will be S square. Right. So you can find easily S will be the square root of Ksp. So it is nothing but 6.2 10⁻⁻13. Understood? So it will be coming out to be 7.87 10⁻⁻7 mole per liter. Right. So this is the unit for solubility. And this is the value 1. Now see for the ny3. When ny3 dissociate, it form Na plus 3Y minus. Understood? So solubility of N plus will be S and this will be 3S. Right. So solubility product will become concentration of N plus into Y minus raised to 3. Now put the value now. So it will be S into 3S raised to 3. So your solubility product for ny3 will be S into 27S cube. So it will be 27S raised to 4 Ksp. Right. So now see, you have to find the S value. So what will be the S? S will be under root of Ksp divided by 27. It will be the fourth root. Right. Why? Power is 4 now. That's why. So its value coming out to be, after putting the value, then it is 3.89 into 10⁻⁻4 mole per liter. So this will be the answer. So hence, so what happened in the S? More solubility of My in water is less than that of ny3. So what is the more solubility value? Whose value is more? So you can see the solubility of this ny3 is more now, because value is more, and this is your this value. This is 10⁻⁻7. 7.7. So it is less value, less. This is more. Right. So more solubility of My in water is less than that of ny3. So you can directly write. So more soluble is which one? ny3. Right. So its solubility is greater than My. So please write this answer. Now see the question number 11. Solubility product of, so it is talking about solubility product of Ag2CrO4, right? AgCl. Next is AgBr. Next part is silver iodide. Are given. So its solubility product is nothing but 1.1 10 raised to minus 12, right? And it will be 1.8 10 raised to of minus 10. So if solubility product of each compound is given 1.8 10 raised to minus 12, 1.8 10 raised to minus 10. Next one is 5 into 10 raised to minus of 13. Next one is 8.3 10 raised to minus of 17, right? So which one of the following salt precipitate if silver nitrate is added? So we are adding silver nitrate to this compound one by one, equal to the number of NaCl, right? Equal to the number of moles of NaCl, NaBr. Next one is sodium iodide. Next will be Na2CrO4, right? So which one? So let's see. So from solubility product, given salt will be solubility. So highest solubility will be at the precipitate. So whose S value will be more? That will be the precipitate forming. So let's see one by one. First compound is Ag2CrO4. So when it dissociate, it forms 2Ag plus CrO4 2 minus. So its solubility is 2S and this is S. So solubility product will be 2S raised to 2 into S. So it will be equal to 4S raised to 3 is equal to, put the value of solubility product, that is 1.1 10 raised to minus of 12, right? So S will be nothing but it is the cube root of 1.1 10 raised to minus of 12 divided by 4, right? So what is the value we are getting as S? So S is nothing but 0.65 10 raised to minus 4, right? So solve this value at home after putting in the calci, right? So I am directly writing here. So please try to solve at home, right? Now see the next case. Next case is second one, that is silver chloride. So when it dissociate, it forms Ag plus Cl minus, right? That will be the Cl minus. Now see. So solubility product will be concentration of Ag plus into concentration of Cl minus. So Ag plus concentration we know, that is S into S is equal to Ksp. So S will be the square root of Ksp, right? We know the value of Ksp for AgCl, right? That is 1.8 10 raised to of minus 10. So the value will be 1.34 into 10 raised to minus of 5. This will be the S value, right? Now see the 4 AgBr, silver bromide. Ag plus Br minus. So solubility product for this will be concentration of Ag plus into concentration of Br minus. So it will be S into S is equal to Ksp. So Ks will be the square root of S, right? So we know the solubility product for silver bromide. So S will be the under root of value, that is 5 into 10 raised to of minus 13. So this will, what will be this value? 0.71 10 raised to of minus 6. Right, now solve for the fourth case, that is nothing but silver iodide. So it is silver iodide. It dissociate to form Ag plus I minus, right? So solubility product will be S square. So S will be the square root of KSP. So S we are getting as 8.3 into 10 raised to of minus 17. So S will be nothing but 0.9 into 10 raised to minus of 8. S is equal to, right? So since solubility of Ag plus is maximum, you can see the value of S, right? That is 0.65. Thus it will precipitate at the last. Maximum value, less precipitation. So write the conclusion here. Hence solubility of Ag2CrO4 is maximum. Thus, it will precipitate at last. Right? So you can just also observe the value. So this is your 10 raised to minus 5. This is 10 raised to minus 6. So when more power is there, less value, right? So it is 10 raised to minus of 8. So in previous slide, for silver Ag2CrO4, its value is more, right? So this value is more. So it will precipitate the last, right? So please write the answer.